So 6.2. Several of our next few notes are going to be about the graphs, and we're just going to touch on a few things in each graph. But first off, you need to know what the parent functions look like. So these are just the original graphs. So a constant. So in the last lesson, we learned about the names of them based on their degree. So a degree of 0 is a constant. Degree of 1, linear, and so on. So a constant graph, that's like y equals just some number c. C for constant. So if you were to type in on your y equals 2, you just put 2, and you look at the graph, it's a straight horizontal line. So y equals some number is just a straight horizontal line. A linear graph is like y equals x. So if you type in y equals x on your graph, it's a line that looks like this. Now quadratic, y equals x squared. So that looks something like this. Now a cubic, that's y equals x cubed. It looks something like that. And now keep in mind, if every time you change a little bit, so if I made that 2x cubed, it would look a little bit different. If I made it x cubed plus 2x squared minus 5, it would look a little different, but it keeps the generic shape. The shape might be more dramatic, but it still kind of looks similar. And as we will do so many examples in graphing these, you will see all kinds. All right, quartic, y equals x to the 4th. So if you graph that, it really looks like the quadratic. It's just a little bit wider. But, adding stuff, it might look like this. That would be another example. You would see more times. Yes, yeah. But that's still not the parent. The parent function, just the plain old y equals x to the 4th. And then y equals x to the 5th really looks like the cubic. But other like common ones that you'll see look more like this that I'm doing in green. No. That would be cubed. It would have another. The 5th would have, because it's the 5th, that means it could cross 5 times, and we'll talk about that. So it has several humps. All right. So one big thing that we look at is called the end behavior. That's talking about which ways the arrows point. So, and the arrows point based on the leading coefficient. So that's the number in the number in the very front, whether it's positive or negative, and the degree. So let's look at your y equals. So we're going to type in something that's a positive leading coefficient and an even degree. So like 2x squared. That's a positive number out front, and the exponent is an even number. And then you graph that. both sides point up. The left side points up, the right side points up. So if it's a positive leading coefficient and an even degree, both sides point up. Now, what if we made that equation, that formula, a negative 2x squared and graph it? Then both sides point down. Nope, I put that in the wrong spot. Hold on. So positive and even. I put that positive and odd. So positive and even, negative and even, goodness, negative and even, they both point down. So negative leading coefficient, but even degree. They both point down. All right, now look at a positive. So 3x to the 5th. That's positive with an odd degree. The left side points down, but the right side points up. And then if we do a negative x to the 5th, the left side points up, the right side points down. And so that holds true with all of your equations.
How do you get it to cross the line multiple times?
Do what?
How do you get it to cross the line multiple times?
It's when you add like x to the 4th plus x cubed, different things like that could make it. All right, so let's look at some examples. So you could type those into the calculator, but it might be faster to refer back to your chart. So this one, number 1, we only care about the highest exponent, your degree, and the number out front. So it's positive, even. Positive, even, which means they both go up. So if it points up, we say it rises, down it falls. So on the left, it rises. On the right, it rises because both arrows point up. Rises to the left, rises to the right. Number 2, we have a negative leading coefficient and an even degree. So negative, even, they're both pointing down. So they both fall. So falls to the left, falls to the right. Number 3, we have a positive, odd, down, up. So it falls to the left, rises to the right. Number 4, negative, odd. So rises to the left, falls to the right. Number 5, we have negative even. So those are both down if I look at my chart. So falls to the left, falls to the right. Then we have positive odd. So falls to the left, rises to the right. Any questions on these? All right. So now we're given a graph, and I want you to determine if it's positive or negative, even or odd. So number 7, they both point down. So if you look at your chart, that would be a negative leading coefficient and an even degree. And then number 8, the left one is down, the right one is up. So if you look at your chart, that would be a positive leading coefficient and an odd degree. Now, we're good on that. So the next thing we're going to do is what are called turning points. So in your graph, if you think about you're crawling up, going down, going up, down. Every time you reach a peak at the top or like the little valley at the bottom, you switch. You switch from going, like if at the top you go up, you turn and go down there. So all of those points at the very peak or the very bottom valley, those are called your turning points. So a turning point is where the polynomial changes direction. So it goes from going up to down, up, down. So if the turning point is higher, so meaning like if it's a top point, like the top of the hill, those are called relative maximums. We talked about maximums and minimums a little bit in quadratics, but if it's at the top, it's a maximum. So those are your max. Yes.
So like the ones in between, like the low ones, will be turning points too, right?
Yep, but they will be considered minimums, relative minimums. And the reason for the relative part is because that's technically, because your graph goes up forever, they're technically not the highest point you could ever find. They goes up forever. It's infinite. But we call them relative. So they're close minimums. It's the maximum point of that general area. Not really the term.
The term?
Not the term.
Turn.
You said turn. Yes, it's the highest or lowest point of that turn. Yep. All right, so we can do these in the calculator, but there are kind of some complicated steps just because the calculator is funky a little bit. All right, so you're only going to learn to use the calculator on these, so you'll get good at doing it. So get your calculator, and there's a function up there, and I want you to type that in. X cubed minus 6x squared plus 7x plus 2. And then go to the graph. And I just sketched the generic shape. So like this point would be a max. This point would be a minimum. All right, so has everybody got it typed in and on your y equals? All right, so right above trace, you see the word calc. So hit second trace, and that goes to a calc menu, and it will calculate any parts of the graph, even the x-intercepts and maybe your vertex. We could have used this last unit.
Where's trace at?
It's right beside of graph. It's at the top. All right, so go down and you see on 3 or 4, you can pick either max or min. I'm going to pick max first just because I'm going to work left to right, so you probably want to follow along with me. So number 4. And it doesn't just straight up go to it because your graph could have several maximums and minimums. So if you look at the bottom, it says left bound question mark. So we're going to move the blinky cursor somewhere to the left of the max. So maybe like right here where I'm drawing in purple. So just make it blink just a little bit to the left. And you hit enter. And then it says right bound. So use your cursor to go over just a little bit. So maybe like right there, just blinking right to the right of it and hit enter. And then it wants you to guess. I don't know why it wants you to guess. You don't even have to move it. Just hit enter again. And it tells you that the maximum is the point 0.71 4.3.
Can I see what the equation thing was?
It's here at the top of your notes.
Oh.
Did everybody get this for the maximum? Now, every time we want to find a new max or a new min, you always have to go back to the calc menu. So second trace. If I had another maximum, I would pick a maximum again, but I don't. I have minimum. So we're going to pick 3. And you're going to take your blinky cursor somewhere to the left. So maybe right here to the left. Hit enter. Move him over a little bit to the right. Hit enter. Hit enter again for your guess. And it tells us that the minimum is negative, or wait, 3.29, negative 4.3. Yes.
On the first max, I got 0.75.
Hmm.
But I got the 4.3.
Then you may go back and try it again. You may not have been all the way to the left. You got to make sure that your blinky cursor is not like above it or something. So go back and retry your max again. And I'll try it too. Like I get 0.7090074.
So when you use the cursor, do you just move it to the? I got lost in the middle of the.
Okay, so see here where I've drawn these little stars?
Yeah.
That's about the area that you want your blinky cursor to be.
Okay.
So when it says left bound, you want to be to the left of your max. So on the left side. And you hit enter, so your blinky cursor should be about right there. And then move all the way over to the right of it, but not very far, just barely past it.
Okay. I see.
Any questions? All right. Number 9. So let's go to this one, and I will work through this one step by step, and then I'll let you finish. All right, so negative x to the 4th plus 4x squared minus 2x minus 1. So this one has 2 maximums and 1 minimum because it had 2 hills and a valley in between. So has everybody got your graph? So second trace. Start with the max. I always go left to right. It doesn't really matter. But we start with the first max. So we're going to click 4 for the maximum. And I'm going to move my cursor to the left of that maximum. So my blinky cursor should be about right there where I made that mark. And then you hit enter. Then you go to the right of it. So just like right here, just barely past it. Hit enter. And then you hit enter again. And we get negative 1.53, comma 5.94.
Wait, whenever you hit second trace, what are you supposed to hit?
Well, I was finding the maximum first, so I think that was number 4. Yep.
Every time I'm hitting it, it's like not doing anything. And I this is my calculator.
Well, you don't have, go back to your y equals. Did you type in the function?
Yeah.
Double check it.
That's weird. Yeah.
So did everybody get that maximum? I don't want to move on. You're not getting it.
Mine's like, it's like 1.8, negative 1.81 instead of 1.53.
Okay. Let me see your calculator. I just can't step over. I'm gonna fall if I try. All right.
Like it's weird because it's getting like close, but the graph looks the same.
Okay. All right. So you are, when you go to second calc, you need to go down to number 4. It looked like you were just clicking trace. You have to click second trace.
I didn't click either one. I didn't click the trace button yet.
Okay. So you're just scrolling through that. You have, yeah, that's why it'll be off a little bit because it's not exact. You have to go second trace and then go down to maximum.
Oh, okay. I was just clicking maximum.
Yeah.
I wasn't clicking the trace.
Yeah. And then it takes you through the left bound, right bound thing. All right. So then if we keep going, I'm going to hit a minimum next. So go second trace. And number 3 is your minimum. So move your blinky cursor just to the left of that minimum and hit enter. Go barely past it. Don't go too much. Just barely past it. Hit enter. And your guess, you don't really have to guess, just hit enter. And your minimum is 0.26, comma, negative 1.25. And then do the same thing. We have one more max. So second trace. Down to number 4. We're going to be just to the left of that maximum. Hit enter. Go to the right. Hit enter. Hit enter again. And we get 1.27, comma, 0.31. Some things that you may see. You may see something that looks like this. 5.27631 e to the negative 10th power. For whatever reason, it won't just tell you 0. But when you have e negative 10, that means you're moving your decimal to the left 10 places, which is essentially 0. So if you see that, if you see the e at the end, it's just 0. Now, if you see something that's like 2.99999, just put 3. Okay. Don't put 2.9. I don't know why it won't. Just round it a little bit for you. Okay. So see if you can finish 10, 11, and 12. All right, number 10, you should get for your maximum negative 2.7, your minimum 0.67, negative 2.48. And if you look here, you can see 11 and 12. If you have any questions, make sure to email me. Have a great day.